Just take a look at this computer. It's an IBMxt clone from around 1985, and by today's standards, it's hilariously underpowered. Its 640 kilobytes of RAM isn't even enough for Chrome browser to sit there doing nothing. 20 megs hard drive? Good luck squeezing even a single modern app onto it. This machine is so out of date that it can't even keep the date. Without an optional add-on card, it loses track of time the moment you switch it off. And yet, this machine can still take you online. It will let you act like a total expert on topic you know zero about, argue with other such experts, destroy friendships in multiplayer, and even download expensive software at a 100% discount. Think I lost my mind? Not quite, but there is one catch. We have to forget the internet and turn to its spiritual ancestor, the Bulletin Board System, or BBS for short. So welcome to part 2 of Dial-Up Stories, where I explore how modems quietly shape our digital world. Today we'll see what a BBS really was, when it felt almost like the internet we know, and when relying on telephone network led to limitations that feel ridiculous by modern standards. And to really put it into the test, I will take this 40-year-old machine down memory lane and bring it back online, like it's the 80s again. Let's dial in. In the previous episode, I wired two computers together through a pair of modems and make them talk using terminal application. Cool, but kind of pointless. Just me typing back and forth with myself. So the question is, how can we make it useful? Here is a thought. First, let's set up one of the computers as a server that runs around the clock. With appropriate modem hardware, this machine will be able to automatically pick up the phone call from the terminal and send it a specific string of characters across the cable. As if by magic, these characters displayed by the terminal will take a form of a message board. Initially it will be completely empty, but the terminal user will be able to send the character E, as in enter, and type their own message. The server will store this message, so that the resubmitted list will include it. Most importantly, however, the saved data will persist beyond the current user's session, and every subsequent caller will also be able to read it. I have simplified things a bit, but that was the principle behind the first bulletin board system and the origin of its name. And although it might seem trivial today, it marked the beginning of a digital breakthrough in the late 70s. However, it wasn't the multi-million-dollar startup we might expect today, but rather a product born of real-life events. In January 1978, Chicago was hit by one of the worst blizzards in its history, the kind that brings a city to a standstill and locks everyone in their homes. You know, just like... no, never mind. So, under those circumstances, two very talented friends, Randy Suss and Ward Christensen, created a virtual version of the bulletin board that hung in the computer club they belonged to. The idea had been in their minds for some time, but it was the snow that finally gave them both the time and a tangible use case to bring it to life. This system was named the Computerized Bulletin Board System, or CBBS for short. I have already shown you the basics of the software, but in the context of the history, the hardware was just as important. Back then, it was standard for a modem to require human intervention to establish a connection. Sometimes you even had to physically place a handset on the audio coupler. This in turn essentially prevented servers from operating automatically. This problem was addressed by Hayes, which in 1977 introduced the AT103A modem featuring auto-answer capability. And by the way, I was struck by how accurately its documentation predicted its potential uses. Just take a look. It lists terminals, BBSs, dial-up servers or routers, multiplayer games, remote work, emails, software downloads, and even ERP systems. Basically, almost all of these things are widespread today, but when this documentation was written, even their names weren't fully established yet. They even suggested making connections at night, when rates are cheaper, probably to make these ideas seem less crazy. No wonder it was this modem that became the heart of the CBBS project, but at the same time it poses the main hardware challenge. It communicated with the computer through the S100 bus, and the problem was that in 1978 the S100 was still an early unofficial standard. In fact, the only thing that was certain at that point was the physical connector and most of the signals routed to the pins. However, there were no established rules governing how device cards would interact with the computer, and the computer itself was in fact one of those cards. Where we would expect to find a motherboard today, there was only a backplane that served merely as an electrical connection. Working with the S100 was therefore more like a designing your own computer rather than simply adding a card to a ready-made machine. Of course, Ward and Randy did a great job here, but the barrier to entry for setting up your own BBS was high. And once again, Hayes came to the rescue by launching its famous smartmodem in 1981. I discussed the modem itself in more detail in the previous episode, but what's important today is that the smartmodem used a much simpler RS-232 interface and implemented a set of simple AT commands, allowing the computer to easily control all of the modem's operations. This in turn made it easy to use with many different types of computers and almost completely relieved programmers of any hardware headaches. From then on, anyone with a home phone line, a modem and a computer could try their hand at writing their own version of BBS. The door was wide open. Alright, so now was the time to just sit back and observe the explosion of this new digital world. Except that it didn't happen that way at all. You see, the world was a completely different place back then. Computers were just beginning to appear in our homes, and the BBS phenomenon itself was a purely grassroots movement with no support from institutions or corporations. The number of servers and users could only grow little by little, driven solely by the work of talented tinkerers who dreamed of all those possibilities of the online world. Yeah. Anyway, one of the early outcomes of their efforts was the creation of the first freeware applications for setting up BBS servers such as RBBS PC. You could finally start running a BBS even without being a programmer. It was also around this time that the typical features of a BBS server took their shape. When logging into one, users could already access discussion threads, private messages, a file download section, and perhaps the most interesting feature of all, the so-called doors. These were specially designed external programs that could take control of the machine from the BBS software to run their own logic independently. Usually these were text-based RPGs, sometimes even enabling some limited interaction with other players on the server. Cool, almost like the internet, but with many absurd limitations stemming from an infrastructure based on the modems and phone lines. And don't get me wrong, it wasn't a bad decision, but rather the only and best option available to BBS pioneers, one that nevertheless confined this technology within certain limits. First of all, BBS servers were connected to a phone line and in those early times were usually located in private homes. Putting a server online made it impossible to call the people living at that number. Today's jokes about servers having set business hours were a sad reality back then. But that's not all. While the BBSs themselves were free, using the phone came with charges. If you were lucky, your provider charged only a flat rate for local calls. If not, you paid for every minute started, regardless of whether the modems exchanged any data during that time. And the telecom company's financial shenanigans didn't end there. The charge depended not only on the duration of the connection, but also on the distance. A call to the neighboring city was usually more expensive, not to mention connecting to another country. Fixed-rate offers generally didn't apply here. And as if that weren't enough, the longer phone line, the poorer connection quality became, and modems either limit the speed or drop the connection entirely. Unlike websites, BBSs thus fostered more local communities. However, this situation changed with the advent of the FidoNet service, which made it possible to organize servers into something resembling a network. At first glance, the BBSs organized on FidoNet continued to operate just as they always had, but with one cool, additional capability. Usually at night, BBS servers would briefly stop serving users and initiate calls with nearby servers to swap message packets with them. And since each server also forwarded message from others, a single message could hop from server to server until, after a whole change of exchanges, it reaches the other side of the world. A true peak of Hobbyists engineering. All of this must have been impressive in the 90s-80s, but the technology was still constrained by its biggest limitation. Once connected, the modems tied up the entire line, meaning that the only one person could use the BBS at the time. Anyone else who dialed into the BBS would hear only a busy signal and would have to give up. That was really annoying. Programmatically, concurrent BBS operations for multiple users became possible in the late 80s, but it still required as many modems and lines as there were simultaneous users. For hobbies, therefore, the barrier barely moved, but for businesses and institutions, it was totally within reach. So, even though BBSs had many reasons to remain confined to a narrow group of hobbyists, their numbers finally took off in the first half of the 1990s. By how much? Well, due to the grassroots nature of BBSs, no one knows for sure. However, I do have two reasonable figures. According to InfoWorld Service, in 1994 there were about 60,000 servers and approximately 17 million users in the US alone. Not bad. The second figure comes from the previously mentioned FidoNet. Since every server in that network had to have its own number and location, we know exactly how many there were. There is a chart on Wikipedia showing that in 1996 the number of nodes reached nearly 40,000. However, looking at this chart, you probably have another question by now. What caused such a sharp decline shortly thereafter? The answer is simple. The internet arrived. From the user's perspective, the transition from BBS to World Wide Web was relatively simple. As long as you had a reasonably modern computer and OS, all you had to do was install some networking software, switch from a terminal to a browser, and dial the internet service provider instead of the BBS server. And that was it. In return, you no longer had to wait for someone else to hang up before you could log in, you didn't have to worry about line quality along the way, and connecting to servers on the other side of the world happened in real time without breaking the bank. But wait a minute. Didn't I just say that those BBS problems stem from the fact that you were dialing in with a modem? And now the same modem suddenly ceased to be the source of problems in the internet era? Well, yes, to some extent. But let me explain. Although from a user's perspective the functionality provided by late BBSs and early websites was quite similar, under the hood almost everything beyond your phone line was different. BBS servers were standalone machines that sat by the phone waiting for someone to call them. When someone did call, they would establish a terminal session with the caller and exchange data by sending text characters back and forth. Even file transfers were carried out by converting binary data into characters that a terminal could process. As long as either party did not hang up the phone, no one else could gain access. A typical point-to-point topology. The internet is a completely different beast that uses the concept of packet switch transmission. All of its nodes are permanently connected and exchange countless data packets containing pieces of what is to be delivered, ranging from the frames of this video to spam emails. Packets always have a sender and a recipient, and their delivery is overseen by the mighty TCP/IP protocol, the backbone of the world as we know it. Nodes typically have a more than one connection to the rest of the network. The physical connection methods varies from copper to fiber optics, but crucially, it is permanently dedicated to the internet. In the mid-90s, connecting users directly to this network was neither technically nor financially feasible. What was possible, however, was connecting to the network a special server equipped with a telephone modem. Much like a BBS, this server waited for a phone call and allowed the caller to temporarily become a leaf in this massive digital structure. This is how the first commercial internet service providers operated, and just as with the BBS, the problem here was also the occupation of the entire line for the duration of the session. This time, however, since internet access was a paid service, it was actually cost-effective to add even dozens of lines and modems to serve many users at once. The change thus took place on many levels. And here we also come to an interesting irony that's relevant to today's episode. Although the internet quickly took over, it also enabled BBSs to survive to this day. Among its wide range of capabilities was the Telnet protocol, which allowed packet switch transmission to be used for establishing terminal sessions. Many BBSs are still active today, and you no longer need to dial in to access them. All you need is the internet. Alright, so how do you do it? Well, to start with, you need to go to a website like Telnet BBS Guide. There, you will find an alphabetical list of active servers, along with a brief descriptions of each. The vast majority of them are accessible only via Telnet, but you will also find some veterans still waiting by their dial-up modems. But the best part is that you can connect directly from your browser, you don't even need to run any additional software. The Telnet client is embedded right on the page. How cool is that? Okay, but I really like to be able to browse those BBSs on my XT machine. The easiest solution in this situation is probably to add a network card to it and use the mtcp package. It provides TCP/IP stack support under DOS and even includes a Telnet client. However, that would completely eliminate the use of modems, and yet that's what I want to play with today. Of course, I no longer have access to a real phone line, and from what I've seen on the website, many active BBSs probably don't either. So I've come with a completely nonsensical and overcomplicated plan that will, however, satisfy my whim. I will connect my XT machines via small telephone exchange to another one, which will act as a relay between the modem connection and the internet. In other words, I will set up a small dial-up ESP server, though a bit absurd, since it's dedicated solely to connecting to Telnet BBSs. For my makeshift relay, I choose one of the machines I restored in a previous episode. It has plenty of RAM, low power consumption, a built-in network card, and almost no graphic capabilities. Sounds like a perfect home server for me. I paired it with a smart modem, and for the XT machine I used Rixon's intelligent modem instead. All that remained was to sort out the software side of things. For the server, I choose FreeBSD as the operating system, because it's a direct descendant of the original Unix from AT&T. Nah, just kidding. It was simply the first OS I had on hand, and it worked here without issues. So now I have three things to do. Communicate with the modem and verify that a connection can be established. Configure the mgt program, which will allow a calling user to log in. And finally, prepare a login script that runs socat, which will link the Telnet session to the serial connection from the modem. But first, a fair warning. I'm about to dive right into plain text config files. If you are not interested in that, skip ahead to the timestamp on the screen. Okay, it's time to log in and find the right serial port. They are listed in the /dev directory, and in FreeBSD, serial ports are named CUAU followed by a number. We have two of them, and I'm betting that 0 is my first serial port with the modem. I'm gonna launch the Minicom terminal to see if anyone's there. Now I'll type a few AT commands to verify that the modem is working. The modem responded with OK, so I think it's OK. And what about dialing? Also OK, and I can even see what I'm typing on the XT machine. Time for another step. Now I need to set up the mgt software, which will automatically answer incoming modem calls and allow logging in. First I need to tell it how to talk with the modem. Modem is on the first serial port, so I'm setting up the port TTUI 0. But wait, shouldn't be CUAU 0 like with Minicom? No, in FreeBSD the serial port is represented by two files. Without getting into details, CUAU is used for outgoing connections and TTIU for incoming ones. Okay, now let's get back to the config. So I want debug on level 6 so I can see if something goes wrong, port speed of 1200 baud, answering after 2 rings, to use the DTR line of the serial port, and finally to initialize the modem with the ATZ command. Now for the second file, TTIS. Here I will tell FreeBSD that mget is now in charge of the serial port input. Great, now all that's left is to reload the configuration and check if anything works. Let's try calling the server from the XT machine. Yes, this is definitely FreeBSD, running in the terminal of a machine that's at least 2 generations too old for this system. Time for the final, third step. Now I need to create a script that bridges Telnet with the serial port. I will use the socket tool, which will establish a Telnet connection to a selected BBS and send it to standard I/O. Since the script will be run by mget, the standard I/O will be the serial port. And for now, I'm hardcoding the A-Net BBS address, I just want a proof of concept. After dialing in, this really cool BBS run by Stingray should appear on the terminal. Okay, final steps. I still need to tell mget to run my script, and I need to set the script's execution permissions. Let's try dialing again. The moment of truth. Will this script work? Well, I have a feeling we are not in FreeBSD anymore. But I guess I got a little carried away wanting to use a 1200 baud modem. Well, I feel like I deserve it, but I won't torment you with my poor decisions. I will just speed up the recordings to an acceptable rate. But whenever you see the terminal clock doing this, think of miserable me waiting for the modem to fetch all the necessary bytes. Alright, before I get started, here is one important disclaimer. I'm old enough to remember when kindness was the norm on the internet, but here I am a complete noob just poking around. If I mix something up, feel free to call me out in the comments. Okay, so first we need to log in. Anyone can create an account, and signing up is just as tedious as it is on website these days, so I will skip that part. After logging in, we are greeted by a list of short welcome messages from previous callers. Take a look at this +++ATH0, it's an old trolling trick as this string caused some modems to disconnect. Luckily, mine is immune to it. Next up is the list of recent callers. Back then, there were no way to get any notifications, so it was good to know if someone had logged in while we were offline. And finally, here it is, the main menu for entire server. Check out all those options available when you type the character in the brackets. Where to start? Well, maybe with the new messages, after all it's a bulletin board. Well, just people who enjoy discovering something new. I have to admit, I felt a little nostalgic for my first visits to internet forums. What else do we have here? Emails. Yes, I know, nothing more fascinating, but notice one little detail. Correct me if I'm wrong, but judging by this menu, this isn't about emails in the modern internet sense of this word. It's about private server messages and those propagating FIDONet packets I mentioned earlier. Cool. Okay, now let's take a look at the Files section. As you can see, it's simply a file browser with folders and short descriptions. It has all the necessary features, but as you can see, it looks more like an operating system tool than a typical download website. I wonder what A-Net NCTV is. Okay, so this is... no, I don't know what it is. But it also brings back nostalgic memories of the graphics included with pirated DOS games. Of course, I've only seen them at the friend's place. Alright, and since we're on the subject of games, I guess it's finally time to check out what we got in that department. The choice is harder than I expected. Okay, but there is no Doom here, so next sane choice would be Tetris. Yep, it's definitely Tetris. Sadly, both the controls and the display were definitely messed up on my build. I guess I will have to try something else. Alright, I got something special here. Legend of the Red Dragon, an absolute classic among text-based RPGs. For the price of a little imagination, the game let you wander around town, slay monsters and collect treasure in the forest, then use obtained gold to buy weapons and level up your character. The most entertaining part, however, was the asynchronous interaction with other human players, that is, killing those who were offline and getting killed yourself when you were offline. Once you reach a high enough level, you could slay the aforementioned dragon. During my playthrough, however, I only managed to become a grave robber, at best. Alright, so we have gone through the birth, rise and decline of BBSs, as well as how to access them these days. I hope you enjoyed the episode, and as always, thanks for watching and see you next time. Bye!